Hello everyone, in this video we're going to turn on the LED using switch, and in this case we have to use the port A and port C. And as you probably can tell, we already used this port C13 in the previous video, and while we are using this port C, actually we use the clock which is called APB2. And so if you take a look at this datasheet, port A and port C, the GPIO-A and GPIO-C is right connected to the APB2 clock. So that's why we used the APB2 enable register in the previous video. But in this case, in this video, we have to use the APB2 enable register as well. Now let's move on to the register coding part. As you probably can tell, we are including this header file, which contains the predefined registers. And that is the only big difference between the previous video and this video, because we made the register on our own using the real address, offered by the reference manual. But in this case, we are using the registers over here, which is already predefined in this file. So just so you know. And I'm going to overview the entire steps we're going to take in this video. Step 1 is for the clock configuration for the GPIO clock. And the step 2 is for port configuration. I mean, step 2 and step 3 is about the port configuration, but step 2 is for the LED output related configuration. And the step 3 is for the switch input related configuration. And then lastly, step 4 is about controlling the switch and the LED. Well, now let's move on to the clock configuration. Well, if you see the reference manual, we are going to use the GPIO-A and GPIO-C. So we have to enable the GPIO clock first. So we have to enable this part over here. So if we transform it into hexadecimal number, it should be 2, no, it's 4 and 1 in hexadecimal number. So it should be 00000014. But I'm gonna clear up this part first, just in case. So we're using the conversion operation and operation to clear up the bits, like this. And then let's go to the port configuration, which is related to LED output. So in this case as well, we're going to the reference manual again. I hope you guys are already familiar with this datasheet, because we already gone through this register already. So we're going to use the push-pull mode for the LED output, and then we're going to use the 10 megahertz for the maximum speed. So it should be 0, 0, 0, 1. But in this case, the reset value is not 0, so we have to clear up this part at least. So it should be 0, 0, 0, 0, F, 0 to clear up 4 beats. Now we have to put this number as well. So 0010, 0010, 0000. There we go. Now let's move on to step 3, which is input configuration. Before we write down the code, we have to go through uh, what the pull-off mode is. And so I've already shown this circuit on the first part of this video. But to understand the pull-off mode, just imagine the situation that the switch is pressed like this. Then the PA0 is right connected to the ground. So PA0 should be zero voltage in this case. But on the other hand, if we unpress the switch like this, then the PA0 is right connected to the 3.3 voltage with the pull-up register over here. So it should be a high voltage, high state. So that's all about the pull-up mode. So we're going to use the pull-up mode for the switch configuration. Now let's move on to the switch configuration over here. So if we take a look at this reference manual, all we take care about is this part because we are using the PA0 for the switch port. Since the reset value is not 0 over here, so we have to clear up this part first before setting up the beats. So it should be 0000, 000, F. There we go. And to set up the input mode, we have to fill in the beats over here with 10 for CNF beat. And the mode beat should be 00 in input mode. So if we transform this beats into hexadecimal number, it should be 8. So 0000, 000, 8. The one thing that I found it very interesting in this reference manual is that we have to control the output data register to set up the input pull-up mode. So if we take a look at this table over here, we're gonna use the input pull-up mode. So we already gone through this part before, but we have to set one beat over here, which is the output data register over here. So lastly, we have to take a look at this output data register for the pull-up mode. Since we are using the port A0, so we have to take care of this part. So this beat should be 1, which is very unusual. So it should be 0000, 0001. There we go. Now let's move on to step 4. Well, our switch is right connected to PA0, so we have to check whether the speed is 0 or 1. So we have to use the AND operation like this. So 0000, 1. Well, when the switch is pressed, like I said before, like I explained before, the PA0 should be, connected to the ground. So the result of this operation would be 0. So, if the switch is pressed, the LED should be turned on. Otherwise, the LED should be turned off. So let's go through the output data register part. Well, our LED is right connected to this 13th bit of this register. So to turn off the LED, we have to set uh, 1 in this bit. So if we transform it into hexadecimal number, it should be 20000. So it should be 0000200. There we go. On the other hand, if we want to turn on the LED, we have to use the conversion operation over here. So this is all about the coding part. So lastly, I'm gonna build this project. Well, the build is completed without any other errors. Yeah, I just unloaded the code right now. So if I press the switch over here, LED is turned on. If I unpress it, the LED is turned off. So it worked pretty well. Well, the one thing that I like to share about with you guys is the SFR tab in the debug session. So if you take a look at this over here, if I suspend the process, uh, the switch related register over here, the value is 1 because I'm not pressing the switch right now. And especially for the 13th bit of output data register, uh, the value is of course 1 because the LED is turned off. But uh, well, if I resume the process again and I'm now pressing the switch and the LED is turned on. And if I suspend the process while I'm pressing the switch, well, the value of the input data register over here is 0, and the the 13th bit of output data register is also 0. So yeah, this is very interesting feature of the STM32Cube IDE. And so if I resume again, and if I suspend the process again, the value is updated again. So yeah, this is all about the demonstration today. So I hope you find it very useful through this video, and see you on my next video. Bye guys.